Okay, I'm still in chapter 3 since we only have done one lesson on complex numbers. And now this 3.2 is on the quadratic functions. You know an awful lot about quadratic functions. You know an awful lot about parabolas. But we're going to take it up a notch. Learning objectives are you're going to recognize characteristics of parabolas. I'm pretty sure that there's a lot of that you already know. You're going to understand how the graph of parabola is related to the quadratic function. Well, of course, that's where the parabola comes from when you graph a quadratic function. You will determine a quadratic function's maximum values or their minimum values. FYI, those are the vertices. If the parabola is opening up, the vertex is at the bottom, that would be called a absolute minimum of that function because nothing goes lower than the vertex when the vertex is in the right position, and this one is that's the lowest. If you flip it upside down, the vertex now will be the highest, so that will be your maximum position. Let's look at the some characteristics of a parabola that we have addressed before. We have the vertex. It's always going to be the lowest or it's going to be the highest. It'll have the maximum value or it'll have the minimum value. In this case, it's minimum. We have the y-intercept, which in this case happens to be right here because I didn't think they drew there. Well, I didn't draw either. There it is. It's crossing the y-axis. So that's the y-intercept. Same thing we've learned before, how to find it applies. Same thing as with lines. And then the next one we'll talk about are the two x-intercepts. An x-intercept can also be called a solution, or it can be called a root. So when we solve a quadratic, we're finding the roots, or we're finding the solution, or we're finding the x-intercepts. That's if our solutions are real numbers. You might figure out that the solutions could be complex numbers, and then you won't see them on the x-axis. That's coming up. Then we have the exact center of this parabola. Exact center. It has to go through the y-intercept. I'm sorry, I didn't mean that. I meant the vertex. That's called the line of symmetry. I just call it LOS. Laugh out soft. No, line of symmetry. Now we're supposed to identify the characteristics of this parabola given this example 1. So this is determine the axis. I didn't see the vertex. It's the vertex first. Then it's the axis of symmetry. Then it's the zeros. And then it's the y-intercept. So this is an easy one. It doesn't take any work. You just have to know what the definitions are. And I trust that you do. So let's do the vertex first. Let's see. I can draw the point and see if it's exactly coming down. I would call that a 3. So I'm going to write vertex. I'm going to give it the order pair. Where does it live? It lives at, this is a 1 right here. That's a 3 down here. It lives at 3, 1. And then let's talk about the y-intercept. The y-intercept crosses the y-axis, and it looks like about here, I think. Or maybe if I zoom in, maybe I can see it more. Oh yeah, I think I could change that. So let me, it's my blasted eyesight. But it clearly is up here. Clearly is on the 7. I'm sure you were telling me that anyway. Clearly on the 7. So we'll put the ordered pair to be 0, 7. And that would be the y-intercept. So I'm going to go y-intercept. And then let's go back to that vertex. Because if we draw a line vertically through that, it doesn't matter how far you go. Lines go forever up, lines go forever down. That's my line of symmetry. It has an equation. It's a vertical line. And it's going through the x value of the vertex. So we say x equals to 3 is the equation of the line of symmetry. It has an equation. The vertex and the y-intercept and the x-intercepts are ordered pairs. So if I go back and find the x-intercept, let's see, x-intercepts, guess what? There are none. There are none on this axis. There's no x-intercept. FYI, that means no real solutions. That doesn't mean there aren't solutions. They're just not going to be real, and it's going to be a little harder to find, but we'll get it done. Let's see. They give all the answers here. X is 3, 0, 7. And what did it say about the x-intercepts? Has no x-intercepts. Has no zeros. Ah, that was another name. Zeros. Sorry. Did I say that earlier? I said roots, solutions. Yeah, so let's talk about it. Let's write it all out. X-intercepts. You see, I don't remember everything myself. X-intercepts, in this case, doesn't exist, but they're also called zeros because the y value is 0. That's why we call them zeros. The y values are zeros. We can call them roots. We can call them solutions. They're all the same thing. That would actually be a pretty good multiple choice question. Let's look at the next part of the lesson. Understanding how the graphs of parabolas are related to the quadratic function. Remember, that was one of the bullets in the objectives for the lesson. I gave you a part from the book. The quadratic function has the highest power of 2. So when I write the equation, I can write f of x or g of x or whatever is ax squared. And the question is, well, what does a mean? Well, a is just a number, and it could be a 1. But it can't be a 0 because then it wouldn't be a quadratic. B is just another number, and C is another number. This formula, f of x equals ax squared plus bx plus c, is in general form. That's the general form of the equation. It's general form because you could set that equal to 0, very simply. But more importantly, everything is on one side if I say equal to 0. General form. Ax squared plus bx plus c. That's the general form. A has to be a number that is not 0. So it can be negative. That would be an upside down parabola. It can be positive. B, on the other hand, could be 0. B doesn't have to be a number. So B can be anything. Technically, C can be any number. And so C is actually the value of the y-intercept because if x's are 0, everything cancels out except for c. So I'll just write that out because it sounds like fun. 0, comma, c is the y-intercept. I know they didn't say that there, but we're looking at this thing, so may as well talk about it. So going back, let's look at f of x equals ax squared plus bx plus c. There's a lot of things we can talk about. For instance, we have two formulas that we will want to be comfortable with. We have the formula for the x value of the vertex. That would be this one right here. Let me just draw it without writing over everything. X equals the opposite of b. That means negative b. So we're going to use the b, whatever number that is, change the sign. If this was plus, we put minus. If this is minus, we put plus, because minus times a minus will become a plus. Keep that in mind. And that's called the x value of the vertex. This bad boy over here is the quadratic formula. X equals, again, minus b plus or minus, I forgot the square root, minus b plus or minus the square root of 4a squared, 4ac all over 2a. And you've had that since definitely Algebra 2, but it's not my favorite formula because it can get kind of ugly. And the problem with it, you have to know what a, b, and c are from the general form. So you're forced, if you're going to use quadratic formula, you have to have your equation in general form. Sometimes that can be some work. And we would set it equal to 0 was what we do. We say ax squared plus bx has to be equal to 0, meaning that's the equation you have. And so that's why it makes the general form. But you can make any equation equal to 0, but the general form happens to have ax squared and bx plus c in that order. So we're looking at each of these parabolas. It's going to take a good amount of work just to talk about what we would use it for. And it looks like we're just concentrating on the vertex and the zeros. Well, good news on this first picture. I don't know if it's good news or not, but there are no solutions or zeros, however you want to call them. There are none because it never crosses the x-axis. But we can still use the quadratic formula, as I should say, no solutions or zeros that are real. That's important because it does have solutions, but they won't be real. And the y-intercept is really easy, but we're not asking for that right now. It's up there. But we do want to know what the vertex is. So I'm going to erase my work there because I need more room. And I'm going to find the vertex first. So to find the vertex, x equals to minus b over 2a. But I don't have an equation, so I'm only putting that in there. But to find the solutions, whether they're real or not, will be opposite of b plus or minus, because there could be two of them, square root of b squared minus 4ac, all of that over 2a. This goes for both of these, except for the second picture. I do have two solutions that are real. And again, I can still find that vertex using the x value. But what happens? To find the vertex, you have to, when you find this x number, it's the same thing as your vertex is going to be minus b over 2a is the x, and the y is going to be f of minus b over 2a. Whatever answer you get for this, you have to plug it into the function right here. So it goes in there, goes here, and it goes here. And the answer you get would be what I'm underlining in red. Whatever answer you get, this is my x, this is my y, and this will be my vertex. I would write that down for sure. We're probably going to have to use it in a minute. This is a repeat. Sorry. But 2 is a charm. Here is one we're going to do. Okay. Let's see what they're going to force us to find. Evaluate the equation of the line of symmetry and the zeros, roots or solutions of the quadratic. Okay. So let's find the line of symmetry. So we're taking it slow, just the line of symmetry. And I hope you don't, hope you can find it. What's the lowest place? Right here. That point. Where is it located? Where does it live? Has to be a vertical line. And I'm going to go off a line probably. That line is your line of symmetry. So my LOS is x equals to whatever number that crosses the x-axis. It looks to me like it crosses at a -2. And what else am I going to find? They said in this one, find the line of symmetry and the zeros. So that's all I want to find. So I found that. I found x equals to -2. Which, by the way, if I was doing the vertex, I know that -2 is part of the vertex. I just don't know. Well, I know what the y value is too. Who am I trying to kid? It crosses at the 3 right here. It crosses at 3, -3. So -2, -3 is the vertex. But all they wanted was a line of symmetry. But it has to cross through the vertex. Now we got to find the zeros. So since I have this in general form, what we do is we identify A, B, and C. So A is 1/2. That's this right here. There's A. Take a minute and write this stuff out. B is a +2. Be careful. Make sure you realize if it's negative, you put negative. And C is the -1. So are you ready for the fun? To find the x's equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. So I'm going to plug everything in. This is really a complicated equation because there's 100 places to make mistakes, and I'll probably make one of them. E equals 2. Let's plug everything in. Opposite of a 2 is a -2 plus or minus square root. B is being squared, and since B is positive, you don't have to fear. It's just a 2 being squared. I always say -4. And inside parentheses, I will write down A times C. A times C. So A's a 1/2 and B's a 2. I know what some of you are wanting to do, but I'm going to put 1/2 times 2. There's a lot of things I could have done first, but I want to show you that it's safer to plug everything in before you start thinking. And then I have a 2 times the A, that's a 2, times my a again was a positive half. So that doesn't look like a half. Well, there. Let me just erase it and just draw it again. 1/2. So let's do the math left to right. So don't forget, this still is x equals. Look at how my steps are. You can clearly see step 1 was the formula. Step 2, I plugged everything in. Next, I'm going to do some simplifying. The -2 doesn't do anything, so I'm going to leave it on the outside. Plus or minus. Inside my square root, I have some stuff to do. Because I have 2 squared. Change that up and make that a different color. 2 squared is 4. Now, I know you're in a hurry to do things, but I'm going to write down -4. Now I'm going to do the mathematics inside the parentheses. 1/2 times 2. If you have 2 halves, that's equal to a 1. And then at the bottom, divide by, all divide 2 times a half. It turns out to also be a 1. Because I have a 2 times a half here. And then 2a was the same thing. So that's a 1. Which is good news because that just goes away. Okay. Now I can do a simplify again. X equals 2 minus 2 plus or minus square root. And did I mess up on something? I'm looking at it. C was negative and I didn't do it. This C was negative. At least I'm seeing it now before I finish it. C is negative, so I'm supposed to put a negative on the 1/2. There's a negative there, which would make this a -1. Okay, I'm glad I caught it before you yelled at me. 4 minus times a negative times a negative is a positive, so it becomes +4. All divided by 1. I won't write that. Let's continue this solution. So x is -2 plus or minus the square root of 8. Now, 8's not a perfect square, so you can't take the square root of it. But if you think about it, 8 does equal to 4 times 2. And 4 is a perfect square. So the magic that I'm going to use next, it is magic, is that this actually becomes a -2 plus or minus, because that means there's 2 answers, the square root of 4 times the 2 inside the radical. But you can break that apart into -2 plus or minus the square root of 4, which is what I wanted to do to make the 8 smaller. That's a perfect square times the square root of 2. Square root of 4 is a 2. So this becomes a 2. So let me move this up. My x's are -2 plus or minus a 2 square roots of 2. Again, what does it mean that there's plus or minus? It turns into this. One of my x's is a -2 plus 2 square roots of 2. And the other x is a -2 minus a 2 square root of 2. So one of my answers will be pure negative, and one of my answers will be pure positive. How do I know? Because -2 minus another negative number, the second one will always be negative. This one here, a -2, added to something bigger than 2, is going to give you a positive number. And so it makes sense if you look at the picture. One number is pure positive between 0 and 1. And I do think that 2 plus 2, -2 plus 2 square roots of 2 will still be a small positive number. And then a -2 minus 2 times the square root of 2 is way over here. Okay? So, unfortunately, This is, I called this a free example because it was in the book, but it wasn't one of the examples we had to do. And I hope I'm right. Uh, you can let me know if I'm wrong, in case I did the math wrong. Another free example. What are they adding? Evaluate this equation for the line of symmetry and the zeros again. So I'm doing another one, okay? This time the vertex is on top. Not a problem. Line of symmetry is a red line. Boom, 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 boom. What's that line? What x does it go through? Line of symmetry is x equals to a -2. Okay? And it has two zeros again. There's two answers. And guess what? They're both supposed to be negative. Let's use quadratic formula again. But before we do, what's my step? My step is to write out my A, write out my B, write out my C. Ah, I see the problem. This problem is not in general form. Bummer. So guess what I have to do? It's not pretty. Bear with me. I'm gonna rewrite this up here because I need to break this apart. This really means y is a -3 times an x plus 2 times an x plus 2 plus 4. So what am I actually having to do? FOIL. Then -3 I just bring down. But I'm going to have to do the x times x, x squared. X times 2 is 2x's. 2 times x is 2x's. Well, you add those together, that gives you plus 4x's. Then you have the last two terms. Last two terms are 2 times 2 plus 4. And then we bring down our plus 4 that's just hanging around. Next step, take this -3 and distribute it 3 times. So here goes. Y equals to -3 times x squared, -3x squared. -3 times 4x, -12x. -3 times 4, -12. Don't forget our friend, the plus 4. Which means I have one more step, and then I have it. This is, by the way, I didn't call it. This is called standard form, by the way. Standard form. Now I'm turning it into general form. General form will be this answer, general form. So y is now equal to 3x squared minus 12x plus 12 plus 4 is 16. So what does that mean for me? A is that was a -3. B is a -12, and C is a +16. Are you ready for quadratic formula? So first thing I write is the formula. Minus B plus or minus square root B squared minus 4AC all over 2A. Plug everything in. X equals to opposite of B. What's the opposite of -12? Got to be +12. I like that, so I don't forget to use it. Plus or minus square root. Be careful. B's got to be squared. That's a -12 all has to be squared. Okay? Minus 4 times what? My two numbers that are A and C. That's a negative 3 times a 16. So let me make a little more room there. Negative 3 times 16. All over 2 times A. And A again was a negative 3. So I'm going to write 2 times a negative 3. That's an important step to plug everything in and watch for your negatives. Make sure that you put your negative number in a parenthesis before you square it, especially if you're using a calculator. X equals to a 12 plus or minus square root. Negative 12 times a negative 12 is exactly 144. Negative cancels. Again, I have a minus 4 times a minus 3 times, what was that number? 16. Let me keep the minus 4 for a minute. Minus 4 times what? A negative 3 times 16. You might have to use your fingers and your toes, but I think it's a negative 48. All over 2 times a negative 3, which is a negative 6. Then I'm going to say, I'm getting tired of it, 12 plus or minus square root 144. Minus times minus is a plus. And if you don't know what 4 times 48 is, it is okay to do scratch work somewhere, especially if you don't have a calculator in your hand, which I don't. 8 times 4 is 32. 4 times 4 is 16, plus 3 is 19, 192, plus 192, all over a negative 6. Now, at this point, I would like to have a calculator. 192 plus 144 is a 6 and a 13. That makes it 336. And, wow, 336. I'm just surprised how this is not a fun problem because the numbers are kind of big. But I'm going to keep going. Equals to 12 plus or minus the square root of 336 all over a negative 6. So the question is, a lot of people will stop there, and I get it. I get it. I'm tempted to, but I'm looking at 336, and I'm asking myself, what perfect squares go into 336? So you can pick up a calculator and actually, does 4 go into 336? It actually does. If you take 336 divided by 4, it's going to give you a whole number. So I could pull out a 4, but let's continue and say, does a 9 go into it? That's the next perfect square, 9. Does a 9 go into it? And I don't think 9 does not go into it. The next perfect square would be 16. And believe it or not, I can tell you 16 goes into it. How do I know? 16 goes into 33 2 times, giving 1 left over, because 2 times 16 is 32. So that 1 goes with a 6, making it a 16, and 16 goes into 16. So if you don't believe me, take out your calculator, and let's take 336 divided by 16. 16 goes into 33 twice. 2 times 16 is 32. Subtract 1, bring down the 6, 21 times. So what does that mean? 16 times 21 is 336. So what will I do with this bad boy? I'm going to write it as A12 plus or minus the square root of the 16 times the square root of the 21, which is not a perfect square. And no perfect square goes into 21 because the only factors of 21 are 7 and 3. Both of them are prime numbers, divided by a negative 6. That turns into a 12 plus or minus a 4, square roots of 21. And each of these are technically divided by the negative 6. So you can say divide by negative 6 here, divide by negative 6 here. Frankly, if you didn't do that step, I'm still proud of you and I would take your answer. But I'm trying to continue it. Negative 6 goes into 12 two times, being negative. Negative 2 plus or minus. And then the 4 reduces by 2, making that a 2, making that a 3. So I'm going to write that as plus or minus square root of 21 divided by 3. I actually like my original answer better than that, I'll be honest with you. I think the first answer I had, 12 plus or minus 4 squares of 21, looks prettier. So I like that. I don't, that's a long problem. Am I going to do any more today? I might be just doing part 1. Getting through all the freebies. Let's finish freebie number 3. And then I think I'm going to stop this video. And we'll call this video 1. It's a lot to think about. Evaluate this equation for the line of symmetry and the zeros. Roots or solutions or of the quadratic. So here it goes again. Look how easy it is. It's just y is x squared. Good news, it's in general form. Because y equals to 1x squared plus 1 plus 0 times x plus a 0. So what's my a? My a is 1. What's my b? My b is 0. What's my c? It's a 0. So x equals to, well, I didn't do the line of symmetry. I'll do that after. Opposite of b plus or minus square root b squared minus 4ac all over 2a. X equals to the opposite of 0 is 0 plus or minus b squared. 0 squared is still 0. 0, I'm going to put it there to hold it place, minus a 4 times a times c. Well, what's 1 times 0? 0. So that's telling me all divided by 2a, I lost the a. 2 times 1 is 2. So that tells me x is a0 plus or minus the square root of 0, all divided by 2. Well, 0 plus or minus the square root of 0 is still 0, divided by 2 is still 0. Only has one answer, 0. Take a look. Da-da! That's the solution. The same place as the vertex. It sits there. And also, this is my line of symmetry. X equals to 0. So I'm done. I got that one. And I found out that the only solution is x equals to 0. That's the only solution. Now, if I was to go on, I'd start talking about the two different forms of quadratics, which we already did. Talked about this standard form, giving a preview. Standard. And this one was the general form. This was that I told you about the opposite of b over 2a. That's how we find the line of symmetry. It's also the first place of the vertex. And then moving on, if you take this answer and plug it into the function, you get the other piece of the vertex. So as I was telling you before, your vertex is going to be always opposite of b over 2a. And that means if you plug that in, that gives you f of opposite of b over 2a. And that's what they just did. That's what they're doing here. Finding out the x component and the y. All that did was, again, it found the x and the y. So I'm going to say that's x, comma, y of your vertex. And I think I'll be stopping real soon here. Yeah, I'm going to stop. That's the end of part 1. That's enough.